Hello learners, welcome to today's education television lesson in physics, and my name is Remy Moyo. In today's lesson, we'll be looking at a topic called magnetism. Magnetism is quite an interesting topic, and at the end of the lesson, I expect you all learners to define magnetism, to define a magnet, to state the properties of a magnet, and to magnetize an iron bar or steel bar, and how you can demagnetize a bar magnet. So in today's lesson, we'll be looking at magnetism. Now, magnetism basically deals with magnets. I'm sure learners, you have all come across magnets in our day-to-day lives. And some of you have had an experience on what a magnet can do. But before we come to all those details, we need to understand the concept of magnetism. What is magnetism? If you look at magnetism, magnetism is a concept, or it is a phenomenon that deals with magnets. I'm saying magnetism is a phenomenon or a concept that deals with magnets. So we are saying magnetism is a phenomenon that deals with magnets. Now, we are saying it deals with magnets. We now need to know what is a magnet. So our next thing we're looking at is, what is a magnet? I know in our day-to-day lives, we can say a magnet. Others would say a magnet is a metal, is a substance that attracts other substances. But I think in physics, if we come to a magnet, it has got its specific definition. And a magnet is defined, or can be defined, as a substance that attracts other substances which are known as magnetic materials. A magnet is a substance which attracts other substances known as magnetic materials. Now, here, if you look at the attraction, it's not every material that can be attracted by a magnet. For example, if you get wood, you bring it close to a magnet. Will the wood be attracted to a magnet? No. If you get a pen, you bring it close to a magnet, you discover that that pen will not be attracted by a magnet. But if you get something like steel or iron, you discover that these materials, they get attracted to magnets. So when we come to magnetism, you find that materials will be classified into two. There will be those materials that can be attracted by a magnet, and those we call them as magnetic materials. And there are those materials that are not and cannot be attracted by a magnet. Those are referred to as non-magnetic materials. And these would include wood, would include pens, and other plastic materials, etc., etc. Now, if you look at these, which we are calling to be magnetic materials, they are sometimes referred to as ferromagnet material. So, we are saying a magnet is a substance. A magnet is a substance which attracts other substances known as magnetic materials. Known as magnetic materials. Here, what is important here is the word which attracts other substances known as magnetic materials. Now, these magnetic materials include we've got iron, we've got steel, we've got cobalt, we also have nickel, etc., etc. These are the most materials that are easily attracted by a magnet. We've got iron, steel, cobalt, and nickel. And these are referred to as magnetic materials. Now, some of the non-magnetic materials are magnetic materials are, we can talk of plastic, we can talk of wood, etc., etc. Now, these non-magnetic materials, as I said earlier on, these are the materials that cannot be attracted by a magnet. Remember, we have said a magnet is a substance which attracts other substances known as magnetic materials. So, the magnetic materials here we have referred them to are, we've got iron, steel, cobalt, and nickel. Meaning that if you have got a magnet, you bring iron close to this magnet, you discover that the iron will be attracted by a magnet. If you bring steel, cobalt, and nickel, they will all be attracted by a magnet. But if you brought plastic, wood, you bring them close to a magnet, you find they will not be attracted. And such materials are referred to as non-magnetic materials. Now, so upon defining what a magnet is, we need now to go into details on what exactly, besides the attraction part of a magnet, what is it that a magnet has, and how can a magnet be identified? Now, you discover that every magnet, every material that is referred to as a magnet consists of two magnetic poles. And these magnetic poles are known as the North Pole and the South Pole. So in short, we are saying, learners, if there is a magnet, wherever you find a magnet, each magnet should always have a North Pole and should always have a South Pole. So we are saying every magnet, or each magnet, consists of two magnetic poles. Namely, we've got the North Pole and the South Pole. So if I was to put a diagram for a magnet, it would look like this. So we are saying if that is a magnet and it's just written like that, then that is not a magnet. Because if it is a magnet, it should have what we are calling, you've got the North Pole and the South Pole. Then this now becomes our magnet. Because we are saying every magnet, or each magnet, consists of two magnetic poles, namely the North Pole and the South Pole. Now, why these magnetic poles? If we were to carry out a simple experiment on a magnet, you discover that we get the magnet and we get the iron filings. Remember, iron filings are simply small particles consisting of the metal, made of the metal iron. If we sprinkle these iron filings on a magnet, you will discover that a lot of them will get attracted at the ends of this magnet. You see, if we were to have, this is our magnet with the North Pole and the South Pole, then we have got the iron filings. These are iron filings getting attracted. You discover that a lot of them will be attracted by the ends here on the North Pole So a lot of them are attracted by the ends, the North Pole and the South Pole, whereas only a few are attracted on the other part of the magnet. What does this imply? This simply means that it's at the end of the magnet where we have got the greatest force of attraction. So we have got that strongest force of attraction right at the ends of each magnet. Hence, we have got the North Pole and the South Pole. So we are saying every magnet consists of two magnetic poles, the North Pole and the South Pole. And why the North Pole and the South Pole? These have been brought about because if we were to sprinkle the iron filings, these are iron filings. And that is a magnet. You discover that a lot of iron filings get attracted right at the end. It can either be at the North Pole and the South Pole, but you find that you're going to have more of the iron filings at the North Pole and at the South Pole, unlike in the middle here. Now, how did we come about the North Pole and the South Pole? Here with me, I'm going to show you, remember, we said amongst the magnetic materials we've got steel, iron, nickel, etc., etc. Now I've got iron with me in form of filings, which we call iron filings. Now I'm going to demonstrate. I've got a magnet with me, this magnet, and it's a non-magnet, and I'm going to bring it closer to the iron filings that I've got here on a sheet of white paper. So if I bring this close, you will see what will be happening. I'm sure you can see. That is the attraction we talk about. Iron filings are getting attracted to the magnet. See? If I was to bring this part also, you see, we're having attraction. So you find that basically this magnet, this substance is a magnet, and this other substance is the iron filings, which is just a magnetic material, which means it is the substance that gets attracted to a magnet. So that's what we mean to say a magnet is a substance which attracts other substances known as magnetic material. So the iron filings are the magnetic material, whereas this is a magnet. As you can see, the magnet, I think as you are trying to see it, we have got two parts there. The other part is red, whereas the other part is blue. Now, why these two colors? Usually, the red part stands for a magnetic pole, and the blue part also stands for another magnetic pole. Now, what we're trying to say is that every magnet consists of two magnetic poles, namely the north pole and the south pole. Now, to distinguish between the two, you discover that the north pole on a magnet is always painted red, like this end here. You discover that this whole part painted red is taken to be the north pole, whereas this whole part painted blue is taken to be the south pole. So every magnet consists of two magnetic poles, the north pole and the south pole. Now, if you come to the attraction, you discover that why do we have north pole and south pole? You discover that if I was to put this magnet down here, then I sprinkle the iron filings. As I'm sprinkling, you discover that I'm also sprinkling right in the middle of the magnet, but it's only at the ends where we have got a lot of iron filings being attracted. So what does this mean? This simply means that at the magnetic poles, that is the north pole and the south pole, this is where we have got the greatest force of attraction. So the reason why we have got the north pole and south pole, these are the two ends on a magnet where we have got the greatest force of attraction, as it can be observed there. We have got a lot of, if I was to lift this, have you seen? We only have a few iron filings that are attracted there, only a few, as you can see, only a few, but we have got a lot of iron filings that are attracted at the end. So the reason why we have got the north pole and the south pole, when a magnet is made, we have got the strongest force of attraction again. Now, how do we determine that this is the north pole and the south pole? Or how did they come about to say this is the north pole, now let's paint it red. This is the south pole, let's paint it blue. Before I go to that, remember I had said that we have got magnetic materials, and amongst them we have got the iron filings. But we also have other materials which are non-magnetic, and for example is the wood. If you look at this wood here, if I was to bring a magnet close to it, you discover there's no attraction there, because that is the wood. Meaning that this wood is non-magnetic material, whereas this is a magnet. I've got two magnets here. As you can see, there's attraction there. I can put this down, I bring, you see, it's getting attracted. It's a magnet, it's getting attracted. If I was to bring another material, see, it's getting attracted, there's attraction there. You see, this can be steel. If I bring a magnet close, it will get attracted. But if I do that, like you can see, we have got this, which is plastic. If I bring our magnet, nothing is happening. So this is non-magnetic material, whereas this is a magnetic material. So we have seen here that magnetic materials get attracted to a magnet, while non-magnetic materials do not get attracted to a magnet. Now, we were talking about how do we know that this is the north pole and this is the south pole. If a magnet is suspended freely, it comes to rest, or it comes to rest pointing to the north-south direction. If you look at the two clamp stands, we have got one clamp stand where wood is being suspended. And remember I've said that wood is a non-magnetic material. Then we have got another clamp stand where a magnet is being suspended. And we can see that we have got the part painted red. See, we've got the part painted red and we've got the part painted blue. Now, if you look at this, when this comes to rest, you discover that actually the red part will always point to the northern hemisphere or the northern pole, whereas the south part will always point to the southern hemisphere. Now, that part which points to the northern part is taken to be the north-seeking pole, whereas that part which points to the southern part is taken to be the south-seeking pole. So if this was to come to rest, definitely there will be no any other direction, but at least it will align itself in the north-south direction. And always if it comes to settle, you discover that the part painted red is always pointing to the north. But if we are to look at the other clamp stand where we have got wood, you will find that the one that has got wood is like the wood has already come to rest. And if you look at the direction it's pointing in the east-west direction. You discover, if I take you back, I think in the other subject, geography, you have got also the North Pole, the Northern Hemisphere, Southern Hemisphere. But when it comes to physics, you discover that in geography, your North Pole is where you are facing. Like you find that, learners, me I'm facing you. So where I'm facing, that's my North Pole. You are facing me, and where you are facing, that's your North Pole. That is according to geography. But according to physics, we have got the Northern Hemisphere, the